We are given this diagram. We're asked to find the area of a parallelogram. We know that area of a parallelogram, area is always base times height. So here we know, remember parallelogram, opposite sides are congruent. So here to here is also 4. So here is also 4. So we need to get the height. And from our 30, 60, 90 theorem, here the height is 3. It states that if you have a 30, 60, 90 triangle, that if here is 30 degrees, that if here is x, the one facing 90 is 2x, while the one facing 60 degrees is root 3x. So that's how I got here as 3. Because this is the hypotenuse, the one facing 90. So here should be 3. Therefore, our area is just 4 times 3, which is 12. We have to find the value of y if the figure is a rhombus. You know, a rhombus, in a rhombus, all the sides are congruent, so they are all equal. So I'm saying that x must be equal to y, and it must be equal to 2x minus 5. So let's now solve this one first. X equals 2x, which implies that x is 2x minus 5. So here 2x minus x, 5. So x is 5. Therefore y is now 2 times 5 minus 5, which is 10 minus 5. The answer is 5. So option C. We are asked to, if the figure is a rhombus, find the value of x. So one of the characteristics of a rhombus is that the vertex angle, the diagonal divides the vertex angle. So see the diagonal. So it divides it into 2 congruent angles. So I'm saying as x must be equal to 2x minus 5. So x is 5. So our answer is C. As if the figure is an isosceles trapezoid, then y is dash. The main characteristics of an isosceles trapezoid, the base angle are congruent. See the base angle. So I'm saying that the base angles are congruent, meaning 2x plus 30 must be equal to 5x. So 5x minus 2x is 3x. Here is 30. Therefore, x is 10. So again, for every quadrilateral, the consecutive angles are supplementary. See consecutive angle. This is a transversal. So if you add whatever that is here and here, it must be 180. If you add whatever that is here and here, it must be 180. So I'm saying that y plus 5x must be 180 degrees. That's consecutive angles are supplementary. That if you add this and this must be 180. So, and we've gotten about the value of y is now 180 minus 5x. So from here 5x is 10. So 180 minus 50, the answer is 130. So our answer is B. So the length of a diagonal of a square of area A is length of diagonal. So let's first draw the square. So this is my square. So this is my square. It's the length of the diagonal. So this is my diagonal, and this is 90 degrees. So we are looking for the diagonal, so let's use D. And you know, in a square, the diagonal bisect the vertex angle. So I'm saying that here they are all 45 45. So this is also 45, 45. So here is 45, 45. So from our 45, 45 triangle theorem, assuming here is x, here will be x based on isosceles triangle. So we want to get the value of d in terms of area. We know that area of a square first. Area is x squared. So that's the first thing we do. And they gave us area as a. So a equals to x squared. So we want to get the diagonal. So from here, there's what we call 45, 45 triangle theorem. That the diagonal is will be x times root 2. We call it 45, 45, 90 triangle theorem. So it states that if you are given any triangle, 45, 45 triangle, 45, 45, 90 triangle, that if here is s, here is s, whatever that is opposite 90 will be x root 2. So it's very easy to understand. So d is x root 2. So we need to write x in terms of area. So from here, area is now x is, therefore x is square root of a. So what you have here is square root of a times square root of 2. So our answer is square root of 2a. So that's the diagonal. So our answer is a.